Hello dear students, this video is about time and space complexity. So time and space complexity are fundamental metrics used to analyze the efficiency of algorithms. They describe how an algorithm's performance scales with the size of its input. So with time complexity and space complexity, simply we can measure the efficiency of algorithm. So based on the input size, how an algorithm performs, it's based on time complexity and space complexity. So actually we measure how much time the algorithm takes in execution and how much memory the algorithm consumes. So actually space complexity nothing but how much memory the algorithm consumes while execution and how much execution time it takes. So time complexity. It is a measure of how the running time of an algorithm increases as the input size grows. So it is a measure of how the running time of an algorithm increases as the input size is growing. How it's measured? It's expressed using any one of the three notations: big O notation, big omega notation and big theta notation. Typically, big O notation describes the upper bound of the algorithm's running time. So, actually there are three notations we can use to express time complexity as well as space complexity. But most popular is big O notation because it describes the upper bound of the algorithm's running time. But other than big O, we also have big omega and big theta notations also. Now, let's come to an example. An algorithm with a time complexity of order of n, which is linear, will take roughly twice as long to run if the input size doubles, while an algorithm with order of 1, which is constant time, takes the same amount of time regardless of the input size. So if the time complexity is linear, which is big O of n, it will take twice as time to run if the input size is doubled. But if the time complexity is order of 1 or big O of 1, which is constant, so it will be regardless of the size of the input, it will always take constant time for this algorithm. Now let's come to space complexity. It is a measure of the total amount of memory an algorithm uses to run as a function of the input size. Now it is also measured just like time complexity. It also has big O, big omega and big theta notations. Typically big O notation is used. An example, an algorithm that creates a copy of the input array would have a space complexity of order of n or big O of n because the memory used grows proportionally with the input size. So that's all about time complexity and space complexity. Thank you.